back to our math class, year 10. I'm going to distribute very short stories for all of us to go through. Can I have someone volunteer to read it for the class? Sure.
Kathy woke up late for school today. She had no time for a shower since the school bus would be at the corner in 5 minutes. But she had to wear something nice, considering it was the day before the dance, and she might see Jim. She looked in her dresser to find it was empty save for 3 skirts and 4 tops. There was a black skirt and a red skirt and a green skirt. The tops were white, pink, yellow, and blue. Maybe she should wear the black skirt and yellow top, or maybe the red skirt and white top. How many different outfits could she wear to school today?
Thank you. So, what do you think about that? Can I have someone come up to the board for me and draw what we have? Like, what information can you put in numbers? Yes, okay. Just a bit.
Do you want me to just write the information you have?
No, just write what information you can put in numbers, and let's give everyone a chance to do that.
Is this the way you want me to do it?
Just any way how you want to do it. We just want to deal with that information. Anyone else wanting to write about the skirts? Taylor, would you?
Page.
Oh,
Yep.
there we go.
Thank you, kids. Thank you. And you want to do?
I was just gonna go one.
All right. Is that right? Do you all agree with that?
Yeah.
Yeah? That was really easy, wasn't it?
Yeah.
Okay. What about if I said, if I added here the second part of the story? Yeah?
The answer was 12, by the way.
That's fine.
Get those lines.
As long as we know how we got that. Sorry? 10. Yeah.
That's the excessive.
25 hats is a lot. She should buy more skirts and pants.
That's right, but they're all dirty, remember? Yeah, so she's not been doing the laundry. Okay, so can you see how there's a twist in the story? Like, can we use a simple method to find the answer here?
No, we can't use the same method.
Why not?
35 has is too much.
It's big, right?
Big number.
Okay, what about if I say, let's forget about the number of hats in the drawer and just focus on the pants. Does this change? Don't look at the board. think about it on yourself.
Color is the same.
Colors will be just any random color.
No, because
No.
there's 3 skirts, so there's 3 pair of pants, so you still get the same answer.
Color of the pants is same.
I want you to think, can you wear a pant and a skirt together?
Yeah, I mean, if you want to look a bit dorky, yeah.
Okay. So let's assume that she's not going to wear a skirt and a pant together. Okay? So what happens? What happens?
Would increase by 27.
I'm sorry, I didn't hear you.
If she can wear a skirt and a pant together,
Yeah?
all these alternatives will again increase by, will become 3 times more.
Okay. That's right. The number of outfits increases. We'll not focus on the number as of now because we want to build our understanding. So, if we say that you're only wearing a skirt or a pant, what happens here? Can I do this? And will this remain the same?
It will remain the same.
Do we all agree? Yeah? Gentlemen there? Derek?
I thought we had, you can either wear a skirt or a pant. So wouldn't it actually go below and make it 4, 5 and 6?
No. I'm just saying, if you are wearing, excuse me. So you're wearing a skirt or a pant. You're
Yes.
not wearing both.
I'm aware of that.
That's right. So we have got 3 skirts and we've got 3 pants.
So,
And because the number is the same, if the number of pants were greater, then we would have had a 4th option here. Does that make
Yeah.
sense?
She's trying to bring up combinations of tops with skirts and tops with pants.
so there'll be twice the number of combinations because you can either wear a skirt or a pant, right?
No, I'm saying, so for example, we're considering that you can only wear a skirt or a pant, but not both together.
That's what I'm trying to get at, that a skirt and a pant is different.
It is, but just pretend you're wearing pants, alright? And then you can either have black, red, or green.
So your pants, alright, we,
Just
No, I understand what is he talking about, because now he's thinking in the shelf, she's
There are 6
having
things.
3 sets of, skirts and then 3 pants, then altogether it comes to 6, and then now that girl is having 6 items.
yeah,
So
that's
we are
right,
under, but
that's
then-
right, but you can only wear one at each time.
I'm aware of that, so as in, it could be black pant, red pant, green pant, then black skirt, red skirt, green skirt, and
That's-
so there'll be 4 tops, 6 different types of, bottoms, and then,
We are
no,
taking it
Forget
into
one
different
of these
sections.
two. Forget, clear, that means then 3 items. Either pant, or skirts, right?
Yes, that's right. Okay, Derek, I'll follow up that with you after the class, yeah? But that's a very good question, and it shows that you're you're trying to challenge our thinking, which is really good. But we'll do that after class, okay? Now, Ankita, you raised something that was combinations, permutations, right? So this is where actually our class is going to. We're going to use this towards probability, all right? Now, for example, if you had to wear stockings, and then you had to wear your shoes, will that affect the order of how you wear what you wear? So you have to wear shoes, but before you wear shoes, you need to wear your stockings. Or if you need to wear your shoes, you have to wear socks, right? So is there a particular order to do that?
Normally, yes.
Yeah? So what does that mean? Order is necessary? Yeah? But in this case, order is not necessary. Okay? So I want you to watch out for 2 things. One is the order. So when the order is necessary, we're looking at permutation, okay? And when order is not necessary, we're looking at combination. Does that make sense? Order is very important when you have to consider, for example, now it's Wednesday and Kathy decides to wear a green skirt, and tomorrow, Thursday, she wants to wear a yellow top. So if we have to find the combination, we will have to consider those two orders. Does that make sense? And if we have to consider the order, then what happens? If we have to consider the order, what happens? Can someone?
She only has 11 options.
Yes, and what does that do to the number of combinations?
Reduces it.
Exactly. Can you share with the class why it decreases?
Because she has one less option the next day. Because she wants to wear the yellow the next day, wasn't it, something like that?
That's right. That's because she's following a set pattern. Does that make sense? Yeah? All right. Now let's throw in the 35 cards back in the drawer. And let's see what we can do to solve this. All right. Any ideas how to work with this?
Are those 35 hats different colors or similar color? Just the same?
Just different designs.
But
Just different designs for the 35 cards. Okay? So when we're dealing with such a problem, which has suddenly taken a spin on itself, and we've got such a great number, it's always best to emphasize, to focus on the bigger number, because that's where the greatest number of combinations lie. So we already know she's got 35 hats in her drawer, which is greater than 3 pair of socks, 3 pair of pants, 4 tops, and 4 skirts. Does that make sense? So this is where we will do what? Have we? So this is where we'll go into our next lesson, and we'll start by doing the factorials. Okay? And we'll see how the factorial helps us to solve such problems. Alrighty? Any questions for today's class? Yeah. Alright, thank you class for being wonderful as always. And Derek, I'll come back to you. You've got the question. And I'll see you next week. Thank you everyone.